Hello my dear students, now we are having second question, and in this question an electron is projected horizontally with kinetic energy of a 10 kilo electron volt and the magnetic field of strength 1.0 into 10 raised to power minus 7 Tesla exists vertically upward. The first part of this question, will the electron deflect toward the right or toward the left? Okay, so here we are having this vertical upward direction, and in this vertical upward direction the magnetic field is exist. Okay, this magnetic field is in vertical upward direction. Okay, and this electron is moving. Let us consider in horizontal direction, and this horizontal direction we are considering as x direction. Okay, so this is direction of velocity. Now to find the direction of force we can use Fleming left hand rule. Okay, if we are using this Fleming left hand rule FBI, this is direction of magnetic field. Okay, this is direction of motion. So magnetic field is vertical upward direction and motion in horizontal direction. So force will be towards the right. According to the Fleming left hand rule, force will be towards the right hand side direction, but it is negative charge particle, so direction of force you have to reverse. So it will deflect towards the left hand side direction, so it will move like that towards the left hand side direction. Okay, so direction of force will be towards the left because it is negative charge particle, so we have to reverse the direction. So the answer of first A part is towards the left. It will deflect towards the left. Okay, now if you are talking about the B part, okay, B part, calculate the sideway deflection of electron in traveling through 1 meter. Okay, so definitely this electron will move on this xy plane. Let us consider this is the y direction, the perpendicular direction is the y direction. So the force will act in this y direction. This is the Fy, force will be in y direction, so it will have one acceleration along the y direction, but in x direction there is no force. Okay, so if we are talking about the motion along the x direction, motion along the x direction, it will perform uniform motion. So you can write x equal to v into t. But if you are talking about the motion along the y direction, okay, so it will have one acceleration, and this acceleration we can find using the force qvb. It is electron, so you can write evb. Okay, there is the force, and from this force we can find the acceleration. It can written as mass into acceleration. It is y direction, so ay. So this acceleration ay, the acceleration in y direction is equal to evb divided by m. This is the acceleration in y direction. Now if you are talking about the displacement in y direction, you can write y is equal to uy into t plus 1 by 2 ay into t square, because it is uniform accelerated motion. But initial velocity in y direction is equal to 0 because it is moving in only x direction initially, projecting along the x axis according to our reference frame. So this uy is equal to 0, you can write 1 by 2. And what is ay? This ay is equal to evb, okay, divided by m into t square. So now this t is the unknown variable, but we are having idea about the motion, the displacement along the x-axis, that is given 1 meter. So we can find the value of t from this displacement along the x-axis, and this t is equal to x by v. So if we are just placing this value of t in this equation, you can find displacement along the y direction, and that y actually we need to find in this b part. Okay, so y is equal to 1 by 2 e into v into b divided by m, and what is t? This t is equal to x by v whole square. Okay, so this y is equal to 1 by 2 e into v into b into x square divided by m into v. So V square, this one V we will cancel out and we will get E into B into X square divided by M into V into 2. Now this M into V is not given in the question. Actually energy is given in the question. So you can convert this M into V, that is the momentum in terms of energy. So this M into V can written as root 2 km. Okay, already so many times we have discussed this concept. If you want to convert momentum into the kinetic energy, so you can write this. Okay, so now this y will become y is equal to EB into x square divided by 2 root 2 km. Okay, only now you have to put the value of this all parameters. So what is this E? This E is equal to definitely 1.6 into 10 raised to power minus 19. That is the charge on the electron. B is given 1 into 10 raised to power minus 7 Tesla. And what is X? It is 1 meter. So 1 square divided by 2 as it is, root again 2 as it is, and K is given as 10 kilo electron volt. So 10 into 10 raised to power 3. So this kilo, and electron volt we can convert into joule by multiplying 1.6 into 10 raised to power minus 19. Now it converted into joule. And M, what is the mass of an electron? That is 9.1 into 10 raised to power minus 31 kg. So you have to solve this and you will get the answer, that is 1.5 approximate. You will get approximate answer 1.5 into 10 raised to power minus 2 centimeter. Okay, so this calculation you have to solve by your own, and only the concept you have to cover. Thank you very much.